All right, so we have carbon-14 dating as our example problem. Hopefully you remember from biology that, that carbon-14 is not the normal isotope of carbon-14. In fact, carbon normally is 12. So carbon-14 is unstable, and so it basically, the nuclei explode at a rate of about half of the nuclei you're having, exploding every 5,715 years. So if you found we assume animals and trees stop eating carbon when they die. That seems reasonable. And so if a tree has half as much carbon as it's supposed to have, carbon-14 is supposed to have, not carbon-14 is supposed to have, we would recognize that it's been dead for 5,715 years, or at least stopped eating at 5,715 years, which is probably dead as well. So if I found a piece of cardboard, only had 15 charcoal, and it had only 15% of the amount of carbon-14 it's supposed to have, we would be able to date it by saying it's got to be older than the 5,715 years. But we're now in a math class, so we can actually calculate how much older by recognizing that the amount of, I'm going to use N for the amount of material on a carbon there is, the change in that is going to be equal to K, okay, times the time, which is good, not times the time, times the amount of material. Because if you have twice as much material, it decays twice as fast because you have twice as many things decaying, right? The more material you have, the more things you have decaying. So we recognize, hey, this is this fun thing we're dealing with right now. We're going to separate a variable. So I'm going to put 1 over n over here and go dn, and then we leave the k sitting over here, dt. And then I'm going to integrate both sides because I separated the variables and I did a good job at that. And I'm going to get kt is equal to ln, absolute value of n, plus c over here. I want to get rid of the e, so I'm going to go n absolute value equals e to the kt. I'm going to recognize I do not want the c up here, so I'm going to put n down here. And I'm even going to go boldly call this n naught, meaning that the amount of initial material is there. Now, I get rid of the absolute value bars by making it plus or minus. We don't know whether n was positive or negative, although we really do know it's positive, but let's just pretend we don't know or don't care. And we end up with this little beastie right here. Okay, and so now we look at this problem and we go, all right, so this is a situation. Now, theoretically, because you took a trig class, you recognize this. This is the exponential growth. And the exponential growth simply comes from the fact that if the amount of stuff, the rate at which things are happening is determined by the amount of stuff you have, this is the only way to deal with how fast something's growing, or in this case, shrinking. So, in order to get k, though, we're missing k. We need k for our equation. We're going to set up our initial conditions. Initial conditions say that I have half as much stuff. Well, it's half as much of what? Well, it doesn't matter. I'm going to say half of the initial amount is equal to the initial amount times e to the k, k being what I don't know, times the amount of years, which is 5,715. Now, some of you might be thinking, wait a second, you really casually went with the n naught being the initial amount. But think about it this way. If I plug in a 0 for here, I would get n equals n naught e to the k0. That's just 0. E to the 0 is just 1. And so the amount I have at time equals 0 is going to be equal to n naught. So initial amount is equal to what I have at time equals 0 by this cute little expression. So in this case, now back to the situation, if half is of the total amount I started with, and this is the total amount I started with, I can actually cancel these out. Now I can calculate that half is equal to e to the 5,715k. Now ln of 1/2, ln of 1/2 is equal to 5,715k. Ln of 1/2 is actually one of those things you're supposed to know. We used to make kids memorize. We don't make you memorize anymore because we're wild and crazy like that. But the answer to the question is 0.693. My calculator gives me a 1.5 as well. And that's 5,715 equals k. So I can divide that out. And I get that k is equal to, negative 1.212 129. Reason why it's negative is because it's, so I times 10 to the negative fourth. And the reason why this is negative is because we're dealing with something that is decreasing, right? So now I get my new equation. It's going to look something like n equals n naught e to the negative 0.000122129 times t, right? All right, so that's my new equation for carbon 14, and then indeed that's the equation you can use for your biology class if you choose to do so. Generally speaking, they're going to give you half-C equations, which is a little bit lame. This actually is a better way to look at the problem. But anyway, let's go ahead and do this. So now I want to know when I have 15%. Well, 15% of my initial amount is 0.15 n naught equals n naught, right? So I have 15% of n naught e to the negative 0.0001219 t. And so I wondered how long it takes to do this. So my n naughts are going to cancel out. My same situation as before. I get 0.15 equals e to the negative 0.0001219 t. I think I may have been missing a letter or number or something. So we got 2 right here. That's the problem. No, not 1, 2, 1. Man, I made a big monkey out of this. Even whatever. Use this number over here. Okay, t. Okay, so I got ln both sides. ln of 0.15 is not one you're supposed to know, and so you get negative 1.8. Again, I'm using my calculator now. No reason why I shouldn't. Negative 0.000122129 times t. So I'm going to divide this by negative 1.2129 times 10 to the negative fourth, and I get the t. Let's go over here somewhere, right? Okay, good. I get that my t is equal to 15,641 years. Now, as a matter of checking it, I would know that 5,700 years, or about 6,000 years, I should have half. 6,000 years should have half of a half, which is a quarter. That's 25%. Half of a half of a half should be 18,000 years, and that should happen when, and that would be, I'd have 12.5%. So my answer should be close to 5,700 times 3. So that's about 17,000, and I would look at this and go, I'm pretty close. It should be reasonable. All right, so that's how you do a problem when involving natural growth curves or things that are dependent on the amount of stuff you have. Again, this applies to pH. This is what you're really doing when you do a pH problem, although your chemistry teacher hides that from you because they don't know you know how to do this. And your biology teacher, when they're talking about half-lives of carbon-14, same issue, and it's done the same way. Your AP Physics C teacher, if you have an AP Physics C teacher, is will throw, when he's throwing at you, air resistance. And now you can do those problems because you should be able to do air resistance. See the first example for an example of that. Again, if you have any questions, please attach a reply to this particular posting, and I can see what I can do to help you out with the other problems. Okay, bye for now.